Welcome everyone. Today we're going to create a procedural octopus. That is to say, an octopus entirely designed with geometry nodes. This node setup has a wide variety of applications. In fact, aside from an octopus, you can also create a squid, a cuttlefish, a kraken, or even an ancient malevolent extraterrestrial being that lies dormant beneath the Pacific Ocean in the sunken city of Rilech. As you can see, the possibilities are limitless. So, let's waste no more time and jump straight into Blender geometry nodes. So, we don't need the starting cube. We can cut this line and create a surface on which we're gonna spawn the tentacles. I'm saying spawn and not instancing because we're not gonna use instances. By definition, instances are repetitions of the same object, which doesn't really work for our model because we want the tentacles to be independent one to the other. So I decided to take a different approach. Shift A, add a grid. Let's make it smaller. Let's add a generate hair curves. We're gonna use the hair and then somehow change the hairs into tentacles. So mesh here and here. Now we don't see anything because the density is really small, so we can plug it here and still nothing. So we use a math node. We multiply by, let's make it 100. And now some hairs started to appear. So let's make them smaller and let's increase the density a little bit. Okay, for now this works. 5 control points are more than enough. So now we have these lines and we want to twist them just like tentacles. So there is a plenty of option within the hair panel. So I decided to go with hair curve noise. Deformation and okay. Now we can see that all the tentacles are moving in one direction. We want to preserve the length and let's add an extra node, because if I increase the noise, okay, you can see that they're kind of starting to move independently, but if I increase the distance, the deformation is going to be really big. But I want this kind of independence. So in order to have all the tentacles moving also in a direction predetermined, I'm gonna use an extra node, which is displace hair curves. So this node has only one feature that I'm interested in, and that's the possibility to displace all the vectors in one direction, or in our case, using one object. I'm gonna create an empty, Shift A, empty, and move it slightly to the side. Now here I can drag the empty directly and use the location as displacement. So now, if I move the empty, all the tentacles are gonna follow, which is exactly the kind of effect I was looking for. So now it's time to give the tentacles some thickness. So let's use a set curve radius. And let's select also a profile. So curve to mesh. And of course, we're going to use a circle. So now we have some thickness, but they are not like tentacles. The tentacles are thicker at the base and thinner at the end. So we're going to use the set curve radius in order to solve this problem with a spline parameter at the radius, actually. Okay, let's make the radius smaller. Let's make it 2 or even 1. Okay, now they're all just like tentacles, but in the wrong direction. So let's move everything to the side and reverse this curve. And boom, that's what I'm talking about. Now we have to add the suckers. Let's first grab all these nodes and group them. Control J and move it here. So we need to select the part of the tentacles that are gonna be covered with suckers. And since suckers usually come in pairs, we actually need 2 strings. So how are we gonna do that? Okay, in the curve to mesh, we have selected a circle with a resolution of 32, which is way too much for our purposes. Let's go to 7. And here we're gonna capture an attribute. So capture attribute is going to be an integer, and we're gonna select an index. So basically every single tentacles, actually we can use a set shade smooth here, and okay, now it's clearer. So basically every string or every strip is one side. With this index we're going to select the first, the second, the third, whatever combination of strings. So we're going to use the UV unwrap applied to a determined selection of indexes. How are we going to do that? Actually, we first have to do one extra step, which is to instance on the tentacles the suckers. So search instance on points, and we need to make to create a join geometry, because if you're going to use this directly, the tentacles will disappear. So search join geometry instances, and okay. And now we can instance toruses, which are very close to suckers in terms of shape. Torus, Okay, this works. So we don't need to see the torus, we can hide it. Go back to our cube and drag the torus here and instance. Of course, the toruses are not aligned and distributed on the entire surface. So we have to solve this problem. The first problem is the alignment, the second is the distribution. So the alignment is a pretty simple solution. So we need a align Euler to vector, and we plug it in the rotation, and we have to capture the normal of the tentacles and distribute the toruses using that vector. So we just capture attribute and we plug it here, vector, and value is normal. And now we can decide how to align, and it's going to be the Z. They're still way too big, so we can scale them to make everything visible. Transform geometry, we can, let's make it 0.1. Okay, much better. So now they're properly aligned, but they're also not scaled, so they're all of the same size and basically distributed on each point of the mesh. So in order to change the scale of the toruses, we're going to use another capture attribute, Shift D, and we're going to use, in this case, a float and face area. So this attribute is going to go in the scale. Now is really small, so we're gonna use a math node to make it visible. Multiply, let's say 100. It's still not enough. Let's try 1000. Face. Let's increase it enormously. Okay, this is pretty much the size we need. And we can adjust later on the exact value, but for now it works. Now, first we have to decide where to apply the suckers. So let's select this attribute here, use the UV unwrap. Okay, and this is going to be plugged in the selection here. But we have first to select where, so we need a compare node. And one more, Shift T. And then a Boolean. So we want is going to be an integer and an integer here too. So we can do it greater than 0 and less than 2. So now we have 2 nice rows of suckers. Okay, now we can group all these nodes and move it down. In order to complete our octopus, we just need very few nodes, which are going to be some spheres, one for the first part of the head and one for the bigger part. So basically that's it. I hope you enjoyed, and stay tuned for the next video in which we're going to complete our model.